Hello everyone and welcome to your partner in education, Agile Rank Mate. Today, in this particular episode of SRMJEEE Search, we're going to be looking at some questions which are samples of the SRMJEEE exam. We're going to be looking at these questions and how to solve them effectively. So let's start off with our first question. This question is from physics. A star is very far from the Earth. If light takes 10 years from it to reach the Earth, calculate the distance between star and Earth. So this is a question on astronomy. Let's go back. Now, when we look at the details given here, light takes 10 years to reach the Earth from that star. Now that means the distance of the star can be written as 10 light years. A light year is a unit of distance which basically is equivalent to how much distance light travels in a year. Now, so 1 light year is the distance light travels in a year, which when calculated equates to around 9.46 into 10 raised to the power of 15 meters. Now, as you can see, the exponent is positive. This means that options B and D are incorrect. Now, since 1 light year is 9.46 into 10 raised to 15, that means 10 light years is basically the same value multiplied by 10. So 9.46 into 10 into 10 raised to 15, which when calculated gives you 9.46 into 10 to the power 16 meters. So as you can see, among the two options remaining, option A turns out to be the right answer. As you can see, the value 9.46 is same across the 4 options. The difference was in the exponent. Since a light year is bigger than a meter, so therefore the exponent has to be positive. B and D are therefore incorrect. And since 1 light year is 9.46 into 10 raised to 15 meters, 10 light years would be 10 times that, which is 9.46 into 10 raised to 16. Option C is actually equivalent to 100 light years. So option A, 9.46 into 10 raised to 16 meters, turns out to be the right option. Now let's look at another question. The length of a body is measured as 3.51 meters. If the accuracy of that measurement is 0.01 meters, you need to find the percentage error in the measurement. Now the original measurement is 3.51 meters. We'll consider that as L. Now what does accuracy here mean? It means that there could be an error of 0.01 meters. So it could be 3.52, but we misread it as 3.51. Or if it's 3.51, but if it's 3.50, but we misread it as 3.51. So that here is the accuracy shown. We represent that as delta L. Okay, now error in measurement is equal to delta L over L. However, when the error has to be shown in percentages, so the percentage error would be delta L over L multiplied by 100. So in this case, delta L is 0.01 over L, which is 3.51 multiplied by 100. So basically we can convert that. So 0.01 is 1 by 100. 3.51 is 351 over 100. So basically it becomes 1 times 100 times 100 over 351 times 100. So basically, we're going to be dividing 100 with 351. So when we do that division here, so basically 351 doesn't go into 100, so we have to write 0 and point. So after point, you can add a 0 to the dividend. So 351 goes into 1000 two times. And when you multiply that, you'll get it as 702. Subtract that, you'll get 298. Again, 351 does not go into 298, so we add a 0. And in this particular scenario, goes in there 8 times, and that will be 2808. So as you can see, if you look at the quotient, it would move on, but we can approximate the quotient to 0.28 percentage. So option C, 0.28 percentage, turns out to be the right option. The other options are incorrect. All you have to do is divide the given accuracy by the length of the body measured and multiply that with 100 to get the percentage error. So option C, 0.28% is the right answer. Now, this is a question from chemistry. This one's pretty easy. Dash have a definite shape and a definite volume. If you look at our options, plasma is basically ionized gases. Gases have no shape and no volume. So they don't have a definite shape or volume, so options D and C are incorrect. Liquids only have definite volume, but not a definitive shape. So option B is also incorrect. The right answer is option A, solids. Now, let's look at another question from chemistry. By what factors does the average velocity of a gaseous molecule increase when the temperature in Kelvin is doubled? So, in order to solve this question, we would need to know the formula for average velocity of a gas molecule. So that would be V equals under root of 8 RT over pi m. So this here is the average velocity of a gas molecule. Now the T here stands for temperature. So from this particular formula, we can get the relation as V would be proportional to under root of temperature. So the velocity of the gas molecule is proportional to the square root of the temperature. Now, this means that V1 over V2 equals under root of given temperature over 2 times under root of 2 times the given temperature. All right. So basically 1 over root 2, that means V2, or the velocity of the gas molecule when the temperature is doubled, would increase by a factor of root 2. Now root 2's value is approximately 1.4. So therefore, option A, 1.4, turns out to be the right option. The other options turn out to be incorrect. So all you have to do is apply the average velocity of a gas molecule, find the relation between velocity and temperature, and find out the factor by dividing the two velocities and the two temperatures together, finding the common factor. And the factor is that V2 would be root 2 times of V1. Root 2 is approximately equal to 1.4. So option A turns out to be the right option. Now, let's look at this question from mathematics. a function f from the set of natural numbers to integers, defined by f of n is n minus 1 over 2 if n is odd and minus n over 2 if n is even. How do we solve this question? We need to find out whether they are 1-1 functions or an onto function. So to rephrase, we need to find out if the given function is 1-1, onto, or both, or none of the above. So let's first do the 1-1 test of the function. All right, now we will consider x1 and x2 as two elements in the domain n. We will consider f of x1 as equal to f of x2. Now, this means we have two scenarios. Actually three scenarios. So when odd, so when we have the x1 and x2 is odd, and f of x1 equals f of x2, then we have x1 minus 1 over 2 equals x2 minus 1 over 2. Now that means we can cancel out 2, so that means x1 minus 1 equals x2 minus 1, which in turn implies that x1 equals x2. So in the odd scenario, if f of x1 equals f of x2, then x1 definitely is equal to x2. So basically the function is 1-1 when both numbers are odd. Now let's try the scenario when both numbers are even. And when that happens, f of x1 equals f of x2 would imply that negative of x1 over 2 equals negative of x2 over 2. Minus gets cancelled, 2 gets cancelled, so basically x1 is equal to x2 as well. So our function is 1-1 in cases where both numbers are even or when both numbers are odd. Now what happens when x1 is even and x2 is odd? In this particular case, you would have minus x1 over 2 equals x2 minus 1 over 2. All right, this is considering f of x1 equals f of x2. So the 2 gets cancelled, obviously. However, we get the function x2 minus x1 equals 1. So basically, that means that x1 is not equal to x2. So if one of them is even and the other one's odd, then that means that x1 is not equal to x2. Now what does that mean? It means if you have the same function given for x equals 2 and x equals 3, then 2 is definitely not equal to 3. So that means the function doesn't contradict itself, which ultimately implies that f of x is a 1-1 function. All right, so f is 1-1. Now that means we can eliminate options B and D. So both of these options say that f is not a 1-1 function. However, we've just proved that f is 1-1. So let's try out the cases for f is onto in order to make sure that we get the right answer. All right, now here we have the onto test for the function f. Now let's look at the codomain of the function. All right. If we look at it, the question says a function f is defined from the set of natural numbers to the set of integers. So basically, the set of integers turns out to be our codomain. That means you would have minus infinity to plus infinity, but excluding the fractions, yeah? So 0, 1, 2, 3, and so on. Now, what is our range? Okay, now let's look at a couple of numbers. let's say, for example, x is -3. That would be -3 minus 1 over 2, minus of -2 over 2, -1 over 2, 0 over 2, 1 minus 1 over 2, -2 over 2, 3 minus 1 over 2, and so on. So that would give us -2, 1, -1, 0, 0, -1, 2, and so on. So as you can see, all the numbers that we get when we solve this particular function across separate cases, we can see that all of them are integers. So basically, the range is also equal to the set of integers. Now, as you can see, the codomain is z, the set of integers. The range is also z. So since the codomain is equal to the range of the function, that means f of x is an onto function. So basically, we've proved that f is both 1, 1 and onto. Now that means option C turns out to be the right option. A says f is not onto, which is incorrect. B says f is not 1, 1, which is incorrect. And D says that it's neither 1, 1 nor onto, which is also incorrect. Option C, f is both 1, 1 and onto, is the right option. Here's another question from mathematics. A set A contains 10 elements. We need to find out the number of relations on A into A. So if a relation is defined between A and itself, we need to find out the number of possible relations. Okay, let's do it for two separate sets in order to find out the actual formula and then apply it for the set A and A. For two sets A and B, we'll consider the number of elements of A as lowercase a, the number of elements of uppercase B as lowercase b. Okay, so basically the number of relations from A to B is defined as 2 raised to the number of elements of A multiplied by the number of elements of B. Okay, which is equal to 2 to the power AB. Now, what happens if you have the relation being defined from A to itself? So we use the same formula. We just write lowercase a instead of b. So 2 times a into a, which is basically 2 times a squared. Now here, the number of elements in A is 10. So lowercase a equals 10. So basically, number of relations is equal to 2 to the power 10 squared, which is equal to 2 to the power 100. So 2 to the power 100 turns out to be the right option. That means option C is the right option. Now let's look at some questions from biology. Hydrogen bonds between cytosine and guanine are 1, 2, 3, 4. So we have the hydrogen bonding between the nitrogenous bases are in 2 formats. You have adenine having double bond with thymine and guanine forming 3 bonds with cytosine. This does not change as we go through the DNA. So basically, guanine and cytosine always have 3 hydrogen bonds between them. So therefore, option C3 turns out to be the right option. And here's our final question for the day. Dash is a group of plants representing one or more ecospecies of common evolutionary origin. So the question itself says it's one or more ecospecies. So that means option A turns out to be incorrect. An ecospecies are genetically distinct geographic varieties of the same thing. They've got geographic variety, population, race of a species. Now, option B says ecotype. Ecotype, when you look at the definition for it, is the same as an ecospecies. So basically, they're synonyms. So ecotype is also a genetically distinct geographic variety. Now, what is a comparium? A comparium is a group of organisms capable of direct or indirect interbreeding, whether offspring is fertile or not. So we're talking about ligers, hinnies, mules. These are examples of comparium. So basically, their parents, so like lions and tigers constitute a comparium, horses and donkeys constitute a comparium, and so on. So that's why option C turns out to be incorrect, because its definition is completely different from the one given above. Now that means the only option that is correct is option D, cenospecies. A cenospecies is a group of plants representing one or more ecospecies of common evolutionary origin. So one or more genetically distinct geographic varieties of plants, they have a common evolutionary origin. That's what's called a cenospecies. So that means option D turns out to be incorrect. Option D turns out to be correct, while the rest of the options A, B, and C turn out to be incorrect. So let me repeat that. A group of plants representing one or more ecospecies of common evolutionary origin is called a cenospecies. So since ecospecies is used in the question, it cannot be the answer. Ecotype is the same thing as ecospecies, so that's incorrect. Comparium is basically a group of organisms capable of direct or indirect interbreeding, even if the offspring doesn't have to be fertile. So option C is also incorrect. That means option D, cenospecies, turns out to be the right option. And that concludes this particular episode of SRMJEEE Search. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. You can also get more information from our channel by hitting the bell icon present below the video. So until the next webisode, take care, stay safe, stay alert, bye-bye for now.